Our next speaker, Stephen White, is Director and Project Manager for Dyteqta International Limited. He has been involved with the development of Dyteqta from the onset, sitting on the initial steering committee and for the trap seal identification system, and later renamed the Dyteqta-System. Since the completion of its research and development at Heriot-Watt University, Steve has been establishing this commercial venture to bring this technology to market. Steve has also sat on numerous product standards and code committees around the world and has presented technical papers at CIB, W62, and at ASPE. Steve has more than 12 years experience in the industry, and his specialty is in drainage venting solutions. So Steve, please please come to the platform.
Okay, good morning. I'm going to talk about drainage defective trap seal identification system. This actually started at the IATMO SARS conference in Los Angeles back in about 2004. It moved on, don't do that, can we? Into recognizing that water trap seals are our only barrier between the drainage system and the living space. But there's no active way of actually knowing whether your trap seals are present within the building. So after the SARS conference in Los Angeles, we moved forward with a steering committee, which IATMO were involved with, World Plumbing Council, Department of Health in the UK, and we've developed a system to monitor water trap seals and also to look for blockages within drainage systems of active buildings. As I say, the SARS was probably the first world-known problem with drainage. I mean, before then, people sort of recognized that smell is an issue. But the SARS, with the 42 deaths in one building, was directly linked to the drainage system, where a pathogen entered the system and traveled upwards and downwards within the building. So Heriot-Watt University have been working and developing a system to monitor the effectiveness of water trap seals. As I say, we identified that water trap seals were dry and the pathogens spread upwards and downwards and out of the building and then into the extractor fans, which spread the infection. It's important to note that airflow in the drainage system goes upwards and downwards, and with the flow within the system, the annular flow with the water on the outside of the pipe, in the middle of the pipe, is air and water vapor droplets, and it's within these droplets that pathogens can spread throughout the system. And currently we only use a water seal as the barrier. There's an ongoing research as well by Heriot-Watt University where they've been looking into possible infections such as MSRA, C. difficile, bird flu, and what they've come up with is measurements. We were quite surprised actually that there is very, very little information about what pathogens are within the drainage system. So when we've been looking at it, we can actually see a circle of cross-infection within the building system. And I don't know the regulations in the United States, but in the UK, they focus heavily on the HVAC environment, the air conditioning, with positive and negative rooms, isolation wards. But what we found is that although they spend millions on having isolation wards and positive or negative air conditioning system, you'd have two basins, one outside the ward and one inside the ward. And what would happen is that the medical staff would wash their hands, go into the ward, treat the patient, wash their hands and leave the ward. And it was all controlled by the air movement through the HVAC system. But the two sinks are actually directly connected or hardwired. So you have a route of contamination into the isolation ward and out of the isolation ward via the drainage system. And if these water trap seals are lost, you can get contamination. And if you think about it, drainage is the only building service that actually interlinks an entire building. Yeah? You have air conditioning systems, you have different water supplies, but when you come to drainage, they're interlinked. They go down the stacks into the main drainage system and then leave the building. So you can have a cross-contamination route throughout the entire building. In the current research that's ongoing, they also measured the environment. And there are biologists and virologists involved in this study. And what they've actually told us is by measuring the water temperature and the humidity within the system is that the drainage system is the perfect environment to grow pathogens. You know, if they were going to culture viruses, this is the temperature range and the environment they'd use to make pathogens within a laboratory. And we have that in the building drainage system. And as I say, air goes upwards and downwards in the building, and they say this was a measurement on a building that's only 3 stories tall, an actual active hospital. And what do we expect from the drainage system? And I'm probably teaching you nothing here because you're all professionals, but we want it to remove waste from the building. We don't want foul odours to enter the habitable space. We want it to be self-cleansing. Now, all these things probably relate to some of the technology that's going to be talked about today, and we're experiencing this around the world where people are designing water-saving systems, and they're going with low flush systems, and what they're not taking into account, and this is probably where codes don't account for, is that to use less water, you increase velocities. So it's particularly with WC flushes. So there's less water, but you flush it at a higher velocity. And it's the velocity of the air pressure within the drainage system that can lead to trap siphonage. Also, there's issues now where it's not self-cleaning. Because there's less water going into the drainage pipe, the pipe sizes are typically staying the same. So your solid transportation is less within buildings. So we're coming across a lot more blockages within drainage systems as well. And I think that's a code issue and a general discussion that needs further understanding, because if you're not getting rid of the waste within the pipework, you're going to get more blockages and you're going to have more problems. It's got to be watertight and able to be maintained and provide ultimately a hygienic environment. You know, drainage is one of the key building services. If it's not working properly, then it's probably one of the most offensive problems within the building through the smell. And as I say, we can get transmission of harmful pathogens. SARS is one, but we also recognise that these hospital infections are coming out, C. difficile, for example. You get cross-contamination. You can get gurgling water trap seals and pipes, bubbling toilets. This is a particular problem in high-rise buildings around the world. And in some extent, you can get exploding water trap seals as well. And I believe John Swarfield's presentation 2 years ago showed you examples of exploding toilets. And this can lead as well for a commercial application with out-of-use hotel rooms and washrooms. My favourite one is the Grand Hyatt in Hong Kong. The lower floors and the bathroom there always explode, so they're always shut. You know, Taipei 101 has experienced problems, and we also know that Burj Khalifa, although not occupied yet, is also experiencing blowing up toilets. And as I say, people recognise smell. They don't always consider pathogen because we can smell it, so we recognise it. And as I say, hydrogen sulfide, methane, ammonia, and nitrogen. It's not such a major problem in an active building, but in buildings that are temporarily used, if you take the Middle East, for example, where you'd have a 50-story building and maybe only 25 apartments are occupied. So if you lose trap seals in these unoccupied rooms, then you get smell and gas build-up within these apartments, and that could lead to potential problems. So currently, if you're a facilities manager, you have to go around and physically service the water trap seals by going and replenishing them. And to say, if we look at why trap seals are typically lost, the main one is evaporation, where it's not replenished. We get self-siphonage, where there's a discharge within the branch. Induced siphonage, where there's a discharge elsewhere in the building. Back pressure, or positive transients, where we get a block of the airflow and we get a water hammer effect and a reflection of positive transient back up the system. And then we get the wind effect as well, where the wind goes over the top of the vent pipes and it just sucks out the water trap seals. And the key factor here is, I'm going to go metric on you, if the water pressure gets, or the air pressure gets to 40 millimeters water gauge, you will start to lose water trap seals within the building. So, typically we look at negative transients, and most codes recognize this and have means of balancing negative transients. And then in tall buildings, we come under positive transients. And this is a particular problem with most high-rise buildings, over 20 floors, and above. And we reckon that about 50% of the buildings around the world experience problems with positive transients within the drainage system. So the defective trap seal identification system, which we call Dyteqta, can be used as a monitoring tool, a building management system for drainage. But it can also be used as a diagnostic tool. If you have problems with buildings, and it's in the UK, typically what would happen is you're a building owner, there's problems with your drainage, and you employ consultants. The consultants will come along and do a questionnaire, and then they run around with torches, try and have a look to see where the problem is. And it takes human interaction to try and find the problem. But if they're not there for peak discharge flow or the loss of the trap seals and don't know what's happening, and the trap seals get replenished, they sometimes come up with inconclusive test results or data of their research to try and identify what the problems are. With Dyteqta, or trap seal identification, we can log the performance of the drainage system, and then we can identify within 12 centimetres where the trap seals are lost within the building. And I say, numerous testings are done. This was actually at Heriot-Watt University, and what we found, which is a very, very common problem, is in plant rooms, which is the bell drain at the top for the condensation vents for the air handling units. And on a daily basis, we were finding that they were dry. So people don't have to do anything until it's raised as an issue. But if you've got the data to prove that these drains are drying out in the plant rooms, you can actually then put a rectification in or relook at the way that you actually do the condensation vents on the air handling systems. So basically, Dyteqta is a computer-controlled unit. It can be remotely controlled, so we can actually carry out tests and monitor buildings anywhere in the world as long as it's connected to the internet. And we set up a monitoring profile, and it can link to any drainage system, any type of system that's out there being used, whether it's mixed-use buildings, a fully vented system, an active vented system. It doesn't really matter to us because we actually work from a defect-free trace, which I'll cover in a minute. And what we use is sound waves, or basically sonar, to send a signal into the system and look where the trap seals are. So it's a time and distance. If its barrier's not there, then it causes an alarm and it tells you where the problem is. So all of this is actually done with the availability of AirNet at Heriot-Watt University, which is a simulation tool. And over the last 30 years, they've been collecting all the boundary conditions of the drainage system in a mathematical model. And this allows us to actually recognize where there's bends, if we've got decreasing pipes. So if you're coming off a 4-inch stack, and then you're going into a 2-inch, an inch and a quarter in a branch, the actual program and the algorithms actually recognize where that is occurring. So it allows us to send our signal into the drainage system, and we know, and basically can map your drainage system for you. So if you take over a building, and you haven't got a full set of drawings, you can install Dyteqta on there, and it'll actually tell you where your pipework's going, which is quite nice. And what we use is essentially an exciter to generate a sound wave. And what we're looking for is either a +1 or a -1 signal, where our barrier should be. So we use an exciter. It's not very exciting. It's just a speaker, essentially. So if we want to play music in the drainage pipe, we can. But obviously that's a bit invasive. So we do a low amplitude pressure wave that we just send in there, about 10 hertz. And that goes into the drainage pipe work, and it's looking for our barrier. So we're looking for +1s where we want it. Dyteqta, or the trap seal identification system, is installed at the top of the building. So we only need an access on the top part of the building to install the control valves to divert the transient into the drainage system. And typically, this is the layout that we have on a manifold fit. So we have one exciter, one electronics cabinet, and that's got the capability to do up to 20 stacks with one control unit. We can actually, if we have a long run on the building, actually do up to 600 stacks with one unit and one exciter. And what we generate in the installation phase is a defect-free trace. So this is the perfect or the optimum protection, so all the barriers are there and there's no blockages in pipe. And any variation from that defect-free trace will generate an alarm to tell you, as I say, within 12 centimetres, a couple of inches, where the blockage or the loss of water trap seal is within the drainage system. And as I say, we install it at the top of the building, and what we can do is integrate it into existing building management systems, or it can be a standalone building management system. And what gives a facilities manager is overall control and understanding that his drainage system is providing the sanitary protection that it's designed to do. So it can be installed on existing buildings or new buildings, even in the commissioning phase. So you have an active monitoring of when, the drainage system when the building is actually in use as well. So if you've got a building that's 50 years old and you're looking to renovate the pipework, for instance, do you need to renovate it? You can run the test and identify if it's providing the sanitary protection. If it's not, then you start rectification or replacement of pipe within the building. Let's say it's a Java-based program, so as long as you get the password and control and you've got access to a PC, you can log into your drainage system and monitor it and set up different protocols of testing. And if you've got, for example, a hospital, you might have areas that you want to monitor on a greater degree, like intensive care, maternity, versus an office part of the building. So you can have greater test cycles. Each test lasts 3 seconds per stack. So what we can do is set up the sequential testing of different components of the building and monitor in greater degrees. And that's working with the customer to decide what level of protection he requires or she requires. I say, that's what the computer program generates for a defect-free trace. And if we expand that, if we get a perfect test, we get a result like that. And then we know that the system is working well. If we find a defect, in this case it took 24 milliseconds to find the loss of the trap seal, in this case trap 26 on the design, then the building or the building management system can generate a signal to the supervisor for an iPhone app, for example, to say that in bathroom 3, toilet 2, the trap seal was lost. And then he can go and replenish the trap seal. And you can have an overall monitoring. So if you're always losing trap seal 26 on a weekly basis, you can then put in a rectification program to see what the problem is. So we can have an alarm. So if it's interlinked to another building management system and you lose trap seals, it'll flash up and tell you exactly where to go. In the UK, in some of the Department of Health buildings and hospitals, they actually employ someone to walk around with jugs of water, just replenishing water trap seals. And that's all they do all day. So it's not a very effective way of providing the barrier. And I say with the trap seal identification system, we can manage it remotely. So it's an active way. Take the human error out of it. And for resources and time, you can tell the employee exactly where to go to replenish the water trap seals. So each stack is tested once at a given time, and that's set out by the overall testing protocol. It's programmable, so we can upgrade it as well. So we can, if we've got an area of the building that we want to monitor on a greater degree, we can just log in and change the protocol. So it works off a defect-free trace, and it's the variance from that defect-free trace tells us where the problem is within the drainage system. So, the world's first monitoring drainage system, because no one else has actually been doing it. But if you think about building services, every building service has a protocol, a building management system, apart from drainage. But again, if building drainage doesn't work properly, then it's probably one of the most offensive failures of the building. I say, it can be used as a diagnostic tool and to map drainage systems. Identifies the issue. So you can work with consultants, you can work with contractors to resolve if there are problems in building design. Monitors the overall effectiveness of the building. It's quick and easy. Installers would probably require a week's worth of training so they can actually establish, to install the components and also to do the setup test as well. So it's ideally for plumbers and HVAC engineers who have the right qualifications to actually install the system. It can fault find drainage. It can provide full-time drainage monitoring. So we would envisage this for public buildings, high-rise buildings, and the hospitals and offices. It can perform drainage system health check. I mean, typically we're talking to customers on commissioning phase, where they've built the building, it operates for a year, and when they do the handover of the building, you can install Dyteqta and sign off the drainage system because you have an active log that it's working effectively. And say, if there are problems, we can actually get involved with consultation and rectification. Say, prime purpose is to identify the loss of water trap seals, and it will identify blockages and holes in pipes as well. Blockages at the moment, if the pipe is blocked by about 15%, then we can detect it, and we're carrying on testing to improve that ratio down. Detects, allowing them to be rectified. The important thing to note is a non-invasive, non-destructive test. So when it's going on, the building occupants don't actually know that that's occurring. So it's actually testing whilst the building is in use. And I say, can provide assurance that the drainage system is fully working. I think that's a key thing to understand because there are a number of buildings out there, and when buildings are getting taller, or mixed-use buildings as well, you know, where it's part shopping centre, part apartments, and part hotel, you know, you get different problems and different loading of the system design. Diagnostic tool, and I say, sonar technology. Think of Red October, you know, when you send the signal out and it gets the ping back. That's all we're doing, and we're doing it within the pipework. Just covering myself there. Installation on a typical 20-stack building would take about 2 days. We're upgrading the system as we're going along because we're carrying out further testing to improve the accuracy. Limited system calibration. Once we have a defect-free test, then that will follow on. If the building's been rectified or the system has changed, we can actually preload the data. So if we have a typical floor height of, being metric again, 3 meters, 2.8 to 3.2 meters, and we know what our typical branch lengths are, we can actually preload the data before we're on the building as well. So it's a quick and easy way of generating the defect trace. And it's remote monitoring. So if you're involved, maybe we're looking after 20 or 30 government buildings, you'd only need one control unit in one part of the building to monitor 20 buildings. Typically, we like to install it in plant rooms, but we can install it externally. It's minimal input. We're not having to repipe systems. We're just having to get into the top of the stacks and connect the manifold valves. It's not very costly in rectification. We're not having to drill holes through slabs, run hard wire anywhere, or transducers all over the building. It only uses one transducer per one exciter as well. So if you take water supply leakage detection systems, they either do pressure drop or they're hardwired with transducers all over the system. With Dyteqta, you just have the one. And that's it, really. Any questions?
Phil Campbell, the United Association Training Department. How does it differentiate when somebody is, if it's sending the signal and somebody's actually using the facility and the trap seal's gone at that moment?
Yeah, in each 3-second test, it's got a test cycle. So each test actually takes 3 milliseconds on the signal. So if it finds that there's water flowing, it just resequences the testing.
Okay.
Where are we with the commercialization process?
We're starting it. We've got our first projects in Sweden on hospitals there. We're talking to various authorities in Hong Kong and the UAE, more on the regulation side as well. Hong Kong are establishing that every building needs to be tested for all building services every 5 years. Currently, their regulation is that the drainage is a visual inspection. I don't know if anyone's been to Hong Kong, but it's probably got the worst drainage anywhere in the world. So they have the worst problems. So they're considering that as well.